Two enterprises operate on identical architecture. Both face the exact same zero-day vulnerability. 6 months later, one suffers a catastrophic ransomware breach, while the other continues business without interruption. The surviving company relied on a formal risk assessment to isolate the threat before the attack began. Many organizations attempt to protect their perimeter by guessing which systems are most vulnerable, applying security treatments before they have even diagnosed the environment. The CISSP framework replaces this guesswork with quantitative analysis. Effective security leadership requires a methodical examination of the landscape. Risk assessment functions as the logical gateway for the entire security lifecycle. It's the mandatory precursor to any risk management strategy. Before allocating budget or deploying software, an organization must identify what can go wrong, analyze the likelihood, and evaluate potential damage. To see how these variables interact, we will construct the 5-step risk assessment architecture from first principles. In enterprise security, the assessment provides the evidentiary data required to build a defensible strategy. We start with a baseline axiom of enterprise security. You simply cannot secure what you do not know exists. Step 1 is asset identification. Defining your valuable data, infrastructure, and intellectual property is the mandatory first variable in our model. This includes customer databases, financial records, proprietary code, and cloud-hosted environments. Once the assets are mapped, we must determine what puts them at risk through Step 2, identifying threats. A threat is an external force or event with the potential to cause harm, such as a state-sponsored hacker, a malware payload, or a natural disaster. A vulnerability is an internal weakness within the system itself, an unpatched server, a misconfigured firewall, or a weak password policy. Threats represent the external forces trying to get in, while vulnerabilities are the gaps in the defense that allow them entry. Security risk only materializes when these two distinct variables intersect. When a specific threat exploits a specific vulnerability to compromise an asset, it creates an attack vector. Completing these first 2 steps transforms an unmapped environment into a technical map of potential failure points. By documenting the intersection of threats and vulnerabilities, the architect can anticipate the specific path an attacker is likely to take. Mapping the attack vector identifies the how. Step 3, analyzing likelihood and impact, identifies the how much. We must answer 2 specific questions. How likely is this event to occur, and what is the exact magnitude of the damage if it does? This calculation produces the primary metric for security management. Risk equals likelihood multiplied by impact. Consider 2 distinct assets within the same network. On the left, a public-facing web server. On the right, an internal test server. Both servers share an identical vulnerability and threat environment, giving both a high likelihood of compromise. The public web server holds customer data. A breach results in service outages and heavy losses. Because the impact is high, the resulting risk is critical. The internal test server holds only dummy data. A breach here is a minor inconvenience. Despite the high likelihood of attack, the low impact results in a low priority rating. Identical vulnerabilities yield radically different risk profiles depending on the impact to the organization. In Step 4, we use a risk matrix to handle hundreds of these calculations simultaneously. The public web server lands in the top right red quadrant, marking it for immediate attention. The test server settles into a lower priority quadrant, reflecting its lower overall risk. The matrix converts these data points into a prioritized list, showing the architect which assets require immediate intervention. This is a necessary filter because organizations have finite budgets and limited engineering hours. The matrix allows security teams to concentrate their defensive efforts on the threats that pose an actual existential risk to the business. Risk assessment simply serves as a strict mechanism for triage, methodically separating the critical threats from acceptable operational noise. Once the risks are prioritized, we move to Step 5, recommend controls. Controls are the mitigations used to reduce risk, such as multi-factor authentication, network segmentation, and encryption. The weight of the control must be proportional to the severity of the calculated risk. We apply expensive, complex controls, like hardware MFA and full disk encryption, strictly to the critical assets. The CISSP philosophy warns that spending $10,000 to secure a $500 test server is an architectural failure. Conversely, leaving a high-impact database protected only by a default password ensures an eventual catastrophic breach. This process ensures that every security dollar spent is tied directly to a measured reduction in organizational risk. This pipeline forms a complete architecture, identifying assets, pairing threats with vulnerabilities, calculating impact, prioritizing through the matrix, and deploying proportional controls. This is a continuous loop. As new systems are deployed or new threats emerge, the assessment must be recalculated. This logic is tested frequently in the CISSP exam. If asked what an organization should do first before implementing a security tool, the answer is to conduct a risk assessment. You must assess the environment before you can act to defend it. Now that we have a model for quantifying internal risk, we must look at the external adversary. In Day 16, we move to threat modeling, where we analyze the specific psychological and technical tactics attackers use to circumvent these defenses. As you prepare for leadership, remember, you cannot manage what you have not assessed, and you cannot protect what you do not understand.